Welcome back to the video, guys. In this video we're going to learn about coordination compounds of transition metal ions. Transition metal ions typically form coordination compounds, and these coordination compounds consist of complex ions. These complex ions are built with a central metal ion and two or more surrounding monodentate ligands. Let's write it down. Transition metal ions transition metal ion typically coordination compounds. Typically form coordination compounds. What are coordination compounds? Coordination compounds made up of complex ions. Made up of complex ions. They are made up of complex ions. And what are complex ions? Let's look at what is complex ions. Complex ions. Complex ion means central metal ion surrounded by two or more monodentate ligands. By the way, what is ligands? Ligand is something, ion or a molecule that attached to metal ion by coordinate bond. An ion or a molecule attached to a metal atom by coordinate bonding. These are called as ligands. Let's look at an example. Let's take nickel, ammonia 6 and Cl2. This is a coordination compound. Now let's look at its structure. Nickel at the center, nickel have a 2 plus charge. Ammonia here, and there will be 6 ammonia on NH3, 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 and NH3. These are not bonded. And there will be 2Cl minus ion outside. And we call this as complex ion, and we call this as the chlorine, 2 chlorine minus, we call as counter ion. Altogether we call this as coordination compound. We call this as coordination. This is a ligand. It is connected to a metal ion. Ligands are Lewis bases. Lewis bases donate electrons to Lewis acid. In this case, the Lewis acid is central metal ion to form dative bonds with them. These arrows are dative bonds. These are dative bonds. And these are ligands. These ligands act as Lewis base, and the central metal ion acts as Lewis acid. Let's write it down. Ligands are Lewis base, and they donate electrons to central metal ion, central metal ion, which is Lewis acid, and they form dative bonds. They form dative bonds. If we want to find the charge of the complex, there is an equation for it. Let's find it out. The charge of complex, charge of the complex is equal to oxidization number of the central metal atom or ion, metal or ion, plus the total charge of all ligands, total charge of all ligands, the oxidation number of central atoms and the total charge of the ligand. Charge of nickel H2O3. Here we know the charge of the complex ion, and let's take it as it is minus 1 is equal to oxidation number. We should find the oxidation number of the nickel, total charge of the ligand. If we find the total charge of the ligand for these H2O, H2O has 0 charge, there is no charge in H2O. Cl3, 3Cl means there are 3 Cl minus ions, therefore 3 charges, and we should mark it as 3 minus charges minus 3. And the answer of the oxide, nickel, oxidation number of nickel, oxidation number of nickel is minus 1 plus 3 equal plus 2 oxidation state. Let's find the charge of the complex of this ion. Okay, the charge of the complex we don't know. Oxidation number we know. It is 2 plus, and it is plus 2, and the total charge of the all of the ligand. NH3 has 0 charge, and 2Cl minus is there, which will be minus 2. Therefore, the charge of the complex is 0. And that's all for this video. Thanks for watching. Meet you in the next video. Goodbye. Take care.